hello and welcome. Good morning, good afternoon, wherever you are in the world, to this PV Magazine Virtual Roundtables Europe 2020. And welcome to our first event, the Asset Management Roundtable. Over the next 2 days, we have 4 roundtable events, more than 50 speakers, I think around 1,800 registrants at this stage, and we'll be talking about a selection of technologies and business topics that really represent the cutting edge of PV in Europe and beyond today. Now, Michael, you've hosted the first PV Magazine Roundtable event back in 2015, I recall. So what can we expect today?
It was the first quality roundtable, by the way. You hosted half a year earlier the first Future PV Roundtable in Berlin. No, the first roundtable was a quality roundtable in Munich, and we started, I mean, our idea was really to start with cases from the real life, and that's what we try to push forward also. Sometimes we deviated a bit, but I think we do that today again.
That's it. So it's learning from real life, learning from real case studies in the field. And I think we have 4 this morning that we'll be going through. And of course, more coming up in the Quality Roundtable, which is in the next session. We also have another kind of credo that we have on our Roundtables events, which is everybody is an expert. Why is that, Michael?
Yeah, I mean, we realized that at the first time when we did this Quality Roundtable, we asked our readers and participants to send us cases and case studies. And that's what we discussed then on these roundtables, what to learn from these case studies. And then we realized that our participants are also experts. And then we thought, okay, it doesn't make sense to have the panels and the floor of the attendees, but everybody's experts. And therefore, we grouped them all around round tables, small round tables. And that was the idea. I mean, later then we introduced panels again, because there are also reasons to do that, why to do that. But I mean, that is our idea. We have a lot of expertise in the audience.
And of course, today and over the next 2 days is a virtual roundtable event, which has some benefits. We have more attendees than ever before, and we also have lots of ways to get involved. Of course, it builds on our PV Magazine webinars, which you may be familiar with. Over the years, we've hosted over 400 webinars in 4 languages. Just last year alone, we had 25,000 registrants to our PV Magazine webinars. But this might be the first time that you're on an event app like this. If you do encounter any problems, do remember we have an info booth, so you can contact our team who are waiting for your inquiries, and they can help you there. Of course, refreshing the browser always helps, pro tip. And we also have live poll questions right throughout each of the sessions. And I really encourage you to answer those. That's valuable feedback for us, and we hope to share some of those results with you. There's video networking also via Zoom rooms. There's a Meet the Speaker Zoom room, and I'll tell you which speakers you can meet after this session, and some group discussions. You can also meet our event partners via their expo area. And of course, there's an attendee-to-attendee chat function. So many ways to get involved. And I also want you to get involved in this discussion here on the main stage. Please interact with our experts, send your questions through, and I'll be kind of feeding them through the discussion as we go. Michael's driving the content. So Michael, what's in store for this morning?
Yeah, I mean, this morning we have the session Asset Management. There we want to discuss the questions how and to what extent project developers and asset managers can increase the yield of their installations, and what can we learn for new installations. But we shouldn't forget that we have also this afternoon, we have the Quality Roundtable, which basically you are also in. We have tomorrow the Sustainability Roundtable, and tomorrow morning and tomorrow afternoon we have the Markets Roundtable, where we discuss opportunities for solar companies to participate in the PPA market and also in the emerging hydrogen market.
That's it. So hydrogen key for sustainability, kind of in the bigger energy transition, and the Sustainability Roundtable is coming up tomorrow, along with a Markets Roundtable, which looks at new opportunities in the European PV marketplaces. More to come on that. But of course, we have sponsors, and they help us to make this event happen and have made our events happen over the years. Michael, what can we say about this?
Yeah, we want to particularly thank our platinum sponsors across the 2 days. That's DuPont, who has been with us since the beginning for the Quality Roundtables, and who is also very much involved in this asset management round session now. We have ET Solar and Smart Energy, who join us both the first time. And for this session, we also have as gold sponsors Ginkgo Solar and Ariel Ray. Ginkgo Solar already sponsored several times in the past years. Ariel Ray is also a new sponsor partner for us. And thank you very much.
And of course, we'll be hearing from some of our sponsors. Some of their experts have great contributions to this Asset Management Roundtable. But Michael, who's the first guest?
Yeah, the first guest is Jacqueline Huyn. Jacqueline is Portfolio Manager at Allianz Global Investors, and she has prepared a feed for thought for us, and she gives us some insights on challenges in portfolio management. And I want to welcome Jacqueline now. Hello,
good morning, everybody.
Jacqueline, great to have you here. Yeah.
Thank you for inviting me. I'm very happy to be here.
So, yes, we are curious to know what are the challenges in the portfolio management which you exercise every day?
Well, I was actually thinking how the solar industry has changed the last 10 years when I started. And I started on the sales side working for a project developer, and at some point I changed over to the buy side working for different investment funds. And when I started, the first investment fund I was working for had a total portfolio of 300 megawatt. And today this is roughly the size of the portfolio I'm in charge of within Allianz Global Investors, and we have different business units active in the renewable energy space, and each of these business units has a portfolio of over a gigawatt. And due to the concentration in the solar industry, most of the players today operate portfolios that range in gigawatts. So for me, the biggest challenge today is how do you manage a portfolio of that scale? And the answer is actually quite simple. Information is key. We generally face three situations. The known knowns. When acquiring assets, we run operating assets. We run a due diligence, and this is how you find out how the assets are performing. If they are underperforming, then you get to know about the root causes. And those underperformance is actually reflected in the price, which is for us as a buyer the opportunity to optimize those assets after the acquisition. Could it be from the legal, fiscal, or technical standpoint? The second situation is the known unknowns. When acquiring newly built or ready-to-build assets with no or with little track record, then based on your experience, from the components, the contractors, the design, the year of commissioning, what is likely to happen down the line. And the third situation is the unknown knowns. And for me, that's the gray area where we need to work on. We accumulate every day, year after year, on each of the plants we operate a huge amount of data. And the consolidation of those data will give us the efficiency we need to run ever-growing portfolios with lean management resources. And I am talking here about digitalization and about data mining. This is the next milestone I see, and I think this is the priority. And tackling yield optimization starts with looking at our own data. I believe that we have in our hands the information we need to perform the technical optimization across portfolios that will actually drive the yield up. So this is how I wanted to start today's discussion. Check your data, master your information, and this is how you're going to know what you have in your hands and how to optimize it.
Thank you very much, Jacqueline. You will be right back on the panel, and on the panel we will also discuss this feed for thought Jacqueline gave us at the moment. But before that, I want to call Lucy Garot-Ill, and she is Technical Regional Manager at DuPont Photovoltaic Solutions. She brought a case study which helps us to discuss these points. So now,
How are you.
Hello, Lucy.
It's nice to be with you.
Great that you are here.
Yes, I brought a few cases to potentially discuss and fuel the conversation with the panelists today.
Yeah. By the way, you will have two cases, and we will now do the first case, and then we will do the second case a bit later.
That's right. So if you want to move to the next slide, here I'm detailing that we have several tools in a toolbox, but using a single tool might actually lead you to the wrong answer. So DuPont has designed a process whereby we cross-reference the information from several tools to diagnose a problem and quantify a problem. So now I'll show you the first case study, which is just the slide after this one. So this case was an interesting case. We were called to investigate because it was obvious there were a lot of hotspots on this installation. But hotspots can participate to the power loss in different manners. So we used thermal imaging to select which IV test we should perform on site, and that allowed us to reduce the testing cost by only testing 50% of this installation. And we determined that there was about 19% power loss at the panel level. We also determined that there was some power loss in boiling, which is more of an environmental factor, and some power loss connected to disconnects, which may be more of a maintenance problems with changes in fuses. So this was an interesting case showing that we had overall, with all instances of power loss included, panel and maintenance and environmental losses, we had more than 20% power loss on this case.
Okay, thank you very much, Lucy. So just to summarize the takeaways, it was very important for this installation to know the power loss very accurately, and you found an effective way to determine this. You will also be right back on the panel, but now I also want to welcome the other panelists and panel guests. Yes, welcome to the panel which we have put together for this panel discussion. You have already met Lucy and Jacqueline. Lucy from Garo from DuPont Photovoltaic Solutions, and Jacqueline Huyn from Allianz Global Investors. I also want to welcome Jan Napiorkowski. He is Global Head of Clean Energy at Arure, which is member of Argo Group. Hello, Jan.
Hi, everybody.
And I want to welcome Stefan Müller. He is member of the board and CEO of the Enerpark. Hello, Stefan.
Hello, everybody. Thanks a lot for the invitation.
And I want to welcome Duncan Bott. He is partner at LCF Alliance. Hello, Duncan.
Good morning. Thank you for having me.
Great that you are here. We want just go into the topic. We have already heard that one point of the case which Lucy has presented was that it was important to know the exact number of power loss. Jacqueline, I would like to address this to you. Is that important for you? Wouldn't you think that one can just exchange the modules, or is it important to have this information, to have this accurate number as asset manager?
You're talking about the exact losses due to the defect of the modules.
Yeah.
Yes, of course, because, I mean, I will give the perspective of institutional financial investors. It's not only about how much losses. I think it has to make sense based on how much it's going to cost. So we need to assess how much losses it means, how are the revenues we will not perceive, how much is going to cost to replace them. I think it's it has to be an equation between the amount of the losses and the cost of recovery. It depends also if the panels are still under warranty or not. It depends on the scale. If it's less than 50%, if it's more than 50%, then depending on the losses, how much motors are impacted. I think the decision we will make will be different. Could it be let it run if it's not significant? It could be if the losses are significant, it's going to be replace the panels. And if we have to replace most of the panels, then we could go to another extreme solution, and then we will have to go back to the bank financing the plant, and we might have to go into more extreme solutions. So yes, it is important to not only have an idea of the losses, but also the cost of repair and the cost of replacement. As I mentioned, at the end of the day, we have to be even between the operation of changing and covering the losses.
Stefan, how would you see this?
Yeah, I think for us it is probably a bit a similar view, but on the other hand, we have two hearts in our body. So on one hand is the owner, because we are the not only the investor, we operate and we keep the plants. So, and here I'm thinking more about pure cash flow. So I only want to see what is the forecast and what I'm generating, and don't want to speak as an asset owner too much about is it now because of a diet failure or something. But on the other hand, as an EPC and O&M partner, we want to ensure that we probably also can do some preventive maintenance. So if we learn more about the plants, then it is for sure much easier to improve the plants in the future. So for us, it is always a bit a mixture of both. On one hand, we want to have more information. On the other hand, we want to have condensed information and not too many data. And I think this is at the moment a bit the challenge.
I mean, the question is maybe also a bit how individual this case is, what we just heard. And we have also on the panel Duncan. Duncan has, we will hear more of him later, but he has a lot of experience with older plants. Would you say what you heard from Lucy is an individual case, or do you have also made this experience that there are this many plants with hotspots and that you don't have really the information?
Yes, I mean, I'm a fan of thermography. It helps to flush out a number of issues, but for me, it's a starting point. And from there, you can really deep dive into real data crunching. But you can be misled heavily. And so from my point of view, I do like the data because you need to make a swift decision. Sometimes if you can understand your return on investment, fine. At other times, you also need to understand, do you need to put a watching brief on a problem? Because while you might have a delaminating module, if it's not yield affecting the moment, you're just going to, should we say, maybe establish a conversation with your module supplier so that you can try and accelerate the warranty claim later. But if it's not yield affecting, then you sort of have to keep revisiting the issue on an ongoing basis. And so it's not just a snapshot of what is today, but it's also the technical information to understand what could it become tomorrow. And also based on the quantity or the quantum of the problem, you know, we've actually also now started just stepping in, because if I've got delamination, for example, or hotspots or some sort of module fault, if the scale is large and you know you're going to have a 4 to 5 to 6 month warranty conversation, then we would actually rather step in, replace the modules, and retrospectively claim the modules back. So at least then I'm not going to have, should we say, revenue losses during my protracted conversation with a module supplier around warranties. So data is key, but you need to understand what is it today and also what is it tomorrow.
Jonathan, do we have already audience questions?
Well, I want to encourage everyone to get involved. We do have a panel of experts here, so I will be feeding these questions into our conversation. There's a lot of discussion about data, and we want data. We want to have a view inside a power plant, but we don't want too much data. I feel that that's one of the messages that we're getting. Do you think there's a role for the more sophisticated technology? You know, we hear about some of these buzzwords, things like AI or data analytics. Is there a genuine role for this in 2020 in terms of managing these large fleets of PV? Perhaps, Stefan, you can speak to this first of all in terms of the data tools that you're using.
Yeah, I think it is a very interesting opportunity, and Jacqueline mentioned this already. I think it has everything to do with efficiency. We have at the moment 400 sites only in Germany, which are under our asset management and under O&M management. So I think it is a real issue at the end to get more information, but have the same amount of operators. So I think we in the last few years, we've seen a lot of interesting opportunities with drones, making new pictures. I think we filled the gap with companies who made pictures analysis and give us the information, what kind of failure it is. So one company made the picture, the other analysis. But on the other hand, we need, I would say, to fill the gap between the picture analysis and the operator, because it doesn't help if we get the information every morning via an email or a short message that there is a diet failure, 200 diet failures on this 20 megawatt plant, if we cannot exchange it. Yeah, so or it doesn't make sense to exchange because the loss over the 10 years are not so high, and the effect of or the impact of investing into exchanging these modules would cost much more than it gained. So I think there is still, as you correctly mentioned, these interesting buzzwords, ML, AI, and so on. But I'm still missing this. Yeah, so I'm still missing the information between the operator and the picture analysis companies. So, and here I think there is a lot of interesting things coming up right now, and we hope that this comes sooner than later.
I mean, we have a lot of topics now. I would like to ask Jan something. Jan Napiorkowski from RLRE, you are setting up insurances for performance ratios, and that means you also have to have plans and you also have to control the O&M. What would you require from the O&M company to do in such cases? Just to exchange models, collect a lot of information, setting up other monitoring systems which may be allowed to do all this analysis with the data? What is your experience?
Well, generally speaking, the more data we have for understanding problems, the better. But that's not necessarily the case when we have to settle a claim very efficiently, right? So for us, in order to understand, evolve our products, improve our pricing models, the more data, the better. And we have enough time and people to really crunch the data, understand really the metrics behind it. But what Stefan was referring to, when it comes to having an issue in the project, and whether this is the project owner or the O&M contractor, it's all about settling a claim quickly. And here AI or proper algorithms, I would say software as a service, which really analyzes the data, is absolutely key. And it's all a trade-off between speed, so quickly understanding what the cost is in order to save cash flows, versus accuracy of the assessed claim. And the balance is very hard. And I totally agree with Stefan that we are not necessarily there yet in order to have a perfect, efficient solution through the softwares and the AI which we have to be able very accurately identify what are the exact causes of a performance ratio loss. Because remember, performance ratio consists of essentially everything. Depends how you define it, but the most widest definitions consist of all the technical failures in the project. So some failure modes can be identified very accurately and very quickly, whereas the others are some form in a gray area and need a joint consensus understanding between the insured and the insurer to agree that, okay, this is the gray area, we accept that this loss is attributable to this failure mode to this extent, and pay out this claim out. Otherwise, it will be just a waste of time to move forward.
Doesn't that depend also whether you have a new installation or an old installation? I mean, when we have a look at the case Lucy brought with us there, the information wasn't there, Lucy. Am I right? You couldn't, from the data, conclude on power losses. But why not, by the way?
That's right. So the problem with the data is, generally speaking, we collect a lot of data. Well, the first question is who's looking at it and how are they looking at it? So softwares are here to try and help us look at the data in the right way. So we see algorithms, for example, about soiling, algorithms about partial shading, which gives you actionable items. So if you've got partial shading, which is varying and growing, you know you need to go and cut the grass. That's one actionable item. And that's what we need to get from the data. We need to get an understanding of what's going on the plant, to get some actionable items to increase the yield of the plant. In this case, though, the data is only as good as your monitoring system and how you set it up. So if you don't have a good transmission of the data to the monitoring system, then you will lose some data, and that will lose you some accuracy in the data. And then you will also have potential problems with, for example, your monitoring stations. They need to measure accurately the data that you're looking for. If this data is not accurate, then you won't be able to draw the right conclusions. So the quality of the data and the accuracy of the data needs to be there.
Why wasn't it accurate in this case?
It wasn't, because there was too much data missing, and the weather stations were not giving us the accurate data all the time either.
And then you did thermography. From the thermography, you also couldn't conclude on the power loss, because I mean there is also work done that you get. I mean, you can also say it can define the thermography, which is standard method, as additional data you just get. So it wasn't possible to do work with them.
Yes, I joined Duncan on this one. Thermography is a good starting point. It lets you see if you have some kind of power loss, but it doesn't let you see how much power loss. In theory, you could recalculate and compute how much power loss from the contrast in your image, but we are not yet there. So there are some thermography companies that propose to assign a power loss and a revenue loss to the thermal image, but these were never tested against the true IV curves on site. So basically, it's rule of thumb, a hotspot is worth that much power loss for the panel. These are good tools to prioritize your actions, because you will quickly see how much revenue loss you get from, for example, a string down compared to a string with 5 hotspots. But they are not good, accurate measurements for the power loss.
Stefan, you are as big EPC and investor in Germany and also globally. You are also constructing new plants. Do you think for new plants these issues are solved, so that when you construct new installations today, that in 5-6 years we don't have the same issues with missing data and these things?
I think we have a quite dynamic situation in the market. We all know that the movement now into PPAs will bring us in a situation that on one hand we have to fulfill much more requirements, which is because we are part of the infrastructure, we are part of, or we are a utility when we sign PPAs with utilities or with corporates. So the request, the demand of technical information is higher. On the other hand, we have to calculate in a different way. So that means you try to save also money. So it is a bit left or right pocket, how and what you invest into the new plants. On the other hand, the systems are getting more intelligent, and this is good. Yeah. So we heard it now from all the other colleagues here on the panel. So there is a very interesting development going on, and I mean, we are thinking about drones which fly autonomous, so that they are probably only like a mobile phone, and they decide to fly by themselves. I mean, there are some legal restrictions in it at the moment, but all these things are coming up sooner than later. We are getting much more information about the data of each string. We are getting more tools at the moment when you do preventive maintenance. We are investing now into a company who gives us, I would say, information about all the old data which we have to look into the future and tell us, okay, probably here you will have some issues in the next few years. When we are doing, for example, analysis of older plants and want to find PID, we don't go around anymore to measure all the strings. We have I would say, call it a machine learning system behind it. So we see patterns and we try to find the issues in advance, or we try to locate them earlier, instead of sending whatever 100 of people into the field and measure each string. I think this is a bit the challenge. Always when you have the situation that you have 300, 400 sites. So to get all these information, the historical information, is a big challenge. But we see more and more super interesting new softwares, new tools, and we are implementing this. So we really try to find out what is good for us, what is good for our sites, to learn from it, so that when we are doing now 30 years PPAs, that we know in advance what we have to do.
What do you Stefan, what do you think of automatic analysis with artificial intelligence of thermographic images?
We've seen it, and we know a few companies are already there in the market. We are working with them, but there is a lot of work behind it in the beginning. So, for example, we have now an offer out or an order out for flying all of our old plants, and these are 350 plants, 1.5 gigawatt. You have to do it in advance before you can make some AI into it to analyze the sites, and only to fly over these plants will take, I don't know, half a year or a year. Yeah. So there is a lot of homework still to be done, so that we can move into these, let's call it algorithm style analysis.
Jonathan, have we got more questions from the audience?
Could bring them up on the screen. We really do want people to get involved. I'm just seeing if we can get some questions up on the screen now. But we are talking about thermography, of course. Stefan is saying that they're doing it, working on really a huge portfolio. Is it something, when you're acquiring a portfolio or looking into an existing PV asset, Duncan, I know you've been involved in that. Is that the kind of first kind of fitness test that you put a PV plant or a portfolio through, thermography, just to give you a kind of ballpark as to the fitness of the PV power plant?
Definitely. So, like I said, it's a jumping off point. It's a means to focus, and that is what we use it for. So there's also the management of your maintenance contractor, and there's the decision of where to prioritize your items. So for me, we will do thermography fairly early on. We will run our own analysis of it. I would say there's a lot of competence and AI coming out of thermography companies, but it's often very misleading, because from my point of view, I buy, should we say, the unloved, the investment opportunities, which are somewhere between sort of 7 and 9 years old. So there are a large number of issues, and the maintenance contractors will always say that, it's going to take a long time. They're very busy. It's a very remote site, and but proportionally, because we buy smaller, so my problems as a percentage have a greater impact. If I've lost a string, my assets are only 1 megawatt in size, and so while it might just be argued, oh, it's Duncan, it's just a string, but proportionally, if it was a 20 megawatt site, I would probably be slightly more accommodating. But it helps me to prioritize my maintenance contractors' works programs. And for me, it's prioritization, and also enables us to try and flush out some really large issues, so that from a project management point of view, we can sort of kickstart the long lead time items, such as warranty claims. And as many of the panelists have already said, it's part of the analysis stacking exercise. You need to start dropping on top of that the IV curve analysis. You start to have dropping on top of that the AC/DC curve analysis. You start dropping on top of that the design, because often when we send in a thermography company, we're not at the benefit to have a full as-built suite. So they don't often have, because the as-built has been lost at some point over the last 9 years. So while I'm stepping in trying to reverse engineer the power plant, I don't always have all of the documentation available. So they will be telling me that I've got shading, when actually it's grass cutting problems. They'll be telling me that whatever it might be. So often they're not entirely accurate either. I'm not saying it's their fault. I mean, you could probably blame the owner, but if I don't have the information either, then we all just need to start moving on. So yeah, it's a great jumping off point. It's a great focusing tool, but it's not actually the real answer to anything.
Thank you very much, Duncan, for this insight. We will continue with this discussion, but I want to move forward the discussion also a bit with the second case Lucy brought to us. Please, Lucy, come and show on the virtual screen with the second case in a moment.
Okay. So I'm going to comment a little bit. There it is. The second case is interesting for a whole different reason. So you see the graph on the left-hand side there. And this was a graph that was extracted from a report to the asset manager. The performance ratio there is pretty good all year. And then what the asset manager would see as well was the yield, the monthly yield for the last 12 months. Now, we came and gathered the reports for a period of 9 months, which gave us some data overlap, which gives us the graph on the right-hand side. And there you can see straight away in this graph form that we've lost up to 45% of the power in the summer months from 1 year to the next. Now, this wasn't part of the report to the asset manager. This is a graph that we constructed by looking at the data from a period of 9 months. Now, in theory, when you lose a lot of power, you should be able to see that in your performance ratio. But in this case, we were not able to see it in the graph with the performance ratio. And this is why there was basically one major mistake. We were talking about data accuracy. In this case, the weather station wasn't giving us the right information. So it was largely underestimating the irradiance, which overestimated the performance ratio. But when you look at the yield, you can see straight away you've lost a lot of power, which is not consistent with any weather pattern that could be expected from 1 year to the next. And the problem here was basically we diagnosed potential induced degradation, which is a problem that is reversible with minimal costs.
Thank you very much, Lucy. I don't know. Is Jacqueline still in the audio line? Okay. Okay. So I just heard that Lucy unfortunately lost connection. So let's see. Maybe she's joining later again. But let's continue. Lucy, you also mentioned you also have an analysis why this could happen that has to do with the way the O&M, the companies sometimes are contracted. Please point out a bit on this.
So in this case, the O&M contractor would suffer a penalty if the PR wasn't met. But there was no target on yield or no expectation on yield. So basically, as long as the PR was met, there was no incentive for the O&M contractor to go and look at the yield. In this case, that means that if I've reached my target on the PR, then I can go and do something else. And so in this assessment, in this contract setup between the asset manager and the O&M contractor, there should be negotiation that makes sense. The O&M contractor can't really influence the performance ratio if this performance ratio is affected by module degradation, for example. So you could hold the O&M contractor responsible for cutting the grass, but you can't hold the O&M contractor responsible for the development of a problem such as PID. So negotiating the contract in this case is very important so that you give the O&M contractor incentives to go and do some troubleshooting, for example.
Thank you very much. I would like to involve the panel again at this point. Stefan, I'm not totally sure whether you also contract O&M providers or you are doing all on your own, but first of all, could that happen also in your case? And what are the key performance indicators which you would set up for O&M providers?
Yeah, I think for us it is a bit different because we, as I mentioned before, we design the plant and we operate the plant. And this is, I would say, what we feel advantage. No? So there is no gap in between. We have one team who designs the system accordingly to the latest standards. Yeah, and this is our engineering team, and the engineering team hands over then the system to the operational team, and they are generally, as Lucy correctly mentioned, they are not really responsible and cannot be responsible if the PR is not good, because the PR has something to do with the design of the system. But what their job is to keep the uptime high and to ensure that our cash flow is working. Beside these, we have, I would say, another, I call it a level of ownership, when the people are in the field, or when, for example, the operational guys and the team, they see something, they automatically hand this then over to another team, which called the systems engineering team. And this team is looking more for general failures. And this can be typical things like PID or LID, but it can be also other things which we have not seen before. And it can be also simple things that, for example, the UV resistance of a cable tie is not perfect. And because of this, we will have in future a failure because of cables are broken, something like this. And this is another team. And then we have inside the whole organization, always, I would say, we are looking for really new things. And this can be things which are implemented after COD, after the connection of the plant. Yeah? And this can be a recoating of the anti-reflex coating of the module, so that we get these, 1 or 2% more. And so these 4 teams are working very close together, and we want to ensure that this level of ownership, that this is our plant and we feel responsible for it, is really in every heart of every person in our team. And
so that
generally this works.
That would mean you couldn't set up such a system with external O&M, by the way.
No, we cannot, and we love to do it by ourselves, because it is our plans. But the good thing is that we even have our own service team. So that means if we do greenkeeping in the field, the guy is not responsible only for greenkeeping. He is responsible for the plant. So he immediately will also shake a bit whatever the structure and see that these screws are not perfectly, or this, as I mentioned, this cable tie is not UV resistant.
But could it, for
this
example,
is an advantage.
Could it all, but let's come to one point of which is really astonishing with this plant, that the asset owner thought, I think he had some suspicions, but he thought basically, oh, my plant is okay, performance ratio is great. Could that happen because it was measured incorrectly? Could that happen?
I don't think so, because we are not looking on the first level. We are not looking at the PR. We are looking at the yield forecast or at the cash flow. So, and if there is a 30% of a gap or 20% gap, we would see it immediately. Yeah. But it is also a bit different, because these are our plans, which we designed, which we built. So there is really, I always use this word, level of ownership. So there is a high level of ownership inside the Enerpark team members and employees, that they feel personally responsible for that this plant is up and running.
Duncan, I suppose that you employ also external O&M companies, I could imagine. If so, what would you set up as key performance indicators for them?
Because no one has really had, without any disrespect, but there's been a very limited amount of ownership, as it were, when we take on a lot of our assets by the nature of where we buy them from. So we look at PR as well as availability. We look at yield, all very separately, but sort of in relationship to each other, because we don't often have the benefit of history either. So we're not entirely sure what the yield should have been. We can theorize based on a technical understanding of what an asset should do. But if you don't have the as built, and you don't have historical maintenance reports, and you don't really have any sort of yield history, then there is a certain amount of, should we say, artistic license.
And what targets do you give then O&M contractors?
Well, I don't want to get too caught up in contract negotiations discussions, because it's a great topic in itself. So we do keep our maintenance contractors tied to a PR guarantee, but the bonus is proportional to yield. So if they want to go and start talking about PR, fantastic. Let's talk about efficiency of design. Because we pay them to do the enhancement. So we say to them, essentially, obviously in conjunction with our data analyst team and our engineering office, we give them a scope of work to go and do their asset improvement. But we also throw, crudely put, an open check their way and say, if you want to do any yield enhancement to optimize your performance ratio, I will pay you to go and do it. And then I will give you a bonus based on your PR guarantee that's tied to your yield. So we give them the opportunity to drive up their potential bonus, but we do keep them focused really on efficiency, because when you're buying, should we say, the unloved, then you need to focus heavily on the efficiency.
I would now like to ask the similar questions to Jan, because I mean it's in his let's say in his offer performance ratio. So what do you think is the best key performance indicators for O&Ms? I mean, you insure the performance ratio, which they guarantee at the end, but do you think there should be others?
Okay, first, I don't want to be too hung up on the word performance ratio in the questions, because we are insuring megawatt hours, and now megawatt hours are derived from multiplying, briefly, performance ratio, which is the technical efficiency of the system, times, let's say, irradiance, okay? So you cannot talk about the one without the other. So that's very simple. So saying whether a performance ratio is a good indicator or not, without assuming that whether it has to be measured correctly, just doesn't make sense. Now, if we assume that everything with the weather is correct, and we focus only on the performance ratio, again, if you relate the performance ratio, this is what Duncan was saying, to the performance of the O&M company, the scope of the O&M services are extremely wide, and in majority of cases, far, far away from what you would call a performance ratio guarantee. They're usually a wider or more defined scope of availability guarantee rather than a performance ratio guarantee. But we have seen gigawatts in the market which are coming with a very sophisticated performance ratio guarantee, which clearly defines how the weather stations are being monitored, maintained, and how the weather adjustments are being made. And those performance ratio guarantees also come with the responsibility to replace, for example, panels in the case of a PID claim, which we're mentioning to before. So talking about the KPIs, we like to have the O&M being remunerated for overperformance of the project. That's not always the case. So I 100% agree with Duncan. And in a perfect scenario, you would see an O&M company that comes with its own software as a service, which really is able to understand in detail the time series data coming off the system, assuming that the hardware is up to date. And then use the yield and the performance ratio, as Duncan said, as the references for the performance of the O&M. But in most cases, we are ensuring the output of the project, so megawatt hours. This includes irradiance risk and also performance ratio.
We'll come to this later. With,
Right. So the performance ratio is just one aspect of a wider megawatt hour guarantee, and the scope of the O&M services are being taken into account into our underwriting. But it all really depends on how much of the expected production of the system we are being asked to insure.
Yeah. I would now like to look, Jonathan, whether there are audience questions.
Please, if we can,
because you shouldn't forget them
on the screen. That's always that would be very helpful. It's great to get our audience involvement, but at the moment we're just not seeing them. But hopefully that can be sorted out very shortly. Yeah. This case was PID though, wasn't it, Michael?
That was PID.
Yeah. So Jan, I'm sure this is something that, as an insurer, that you've dealt with. It's an issue that it seems like we've been speaking about for a very long time. How do you kind of prescribe, asset owners and your customers deal with PAD when it is encountered in their assets? How prescriptive can you be?
We don't prescribe how the asset manager or how the owner of the project will deal in a case on how they want to replace their modules in terms of speed and scope. What we prescribe is how we will evaluate the claim from an insurer's point of view, right? And now the goal is to make sure that the sample testing and the procedure is defined in a policy, predefined in a policy, that if a claim of module failure happens, we have a clearly defined procedure on what is the sample which will be tested in order to be representative for the entire population of the underperforming modules. And here is the key, which is how to identify the population. This is, I think, what Lucy was referring to, especially before, because we can have very precise processes on how to extrapolate the results of the sample testing when it comes to cause and degree of degradation to the entire population. But it is not necessarily easy to quickly identify what is exactly the population of the underperforming modules. And now the second aspect is we have to differentiate between policies which pay for replacement, let's say, of modules, or policies which pay for loss in revenue, like a production guarantee, right? In a production guarantee policy, which at the end of every 6 months or every year pays a corresponding loss in revenues corresponding to the loss in, say, module degradation, we have language which prescribes within a certain time frame, let's say X weeks, that we give a certain time frame within the PID issue or the module issue has to be fixed in the projects, like say 6 months, right? So we pay a corresponding loss in revenues related to the underperforming modules, let's say as an example, up to 6 months, but we expect that the project and the module supplier resolve the claim within 6 months. Now, if the module supplier is not around, this is a catastrophic case of a loss for us, because this means that we don't prescribe the owner of the project to replace those modules. And if they decide themselves not to replace the modules or come to an agreement with us, we may have to pay a corresponding loss in revenues for the remaining, 10 years of the project. So this is a catastrophic case, but this is a case which is covered under the policy.
Thank you very much, and we'll come back to the insurance later after the panel. I just welcome back Jacqueline. She dropped out. Jacqueline, we discussed beforehand, so I think you know the case and the arguments Lucy made about the key performance indicators for O&M companies. We had discussed the case that the PR was stable, but the yield dropped quite a lot. And but the O&M company was contracted only on behalf of with the target of the performance ratio. So you think you have thought also a lot about transparency in the value chain and also about how to involve the O&M. So what do you think are the best key performance indicators for O&M service providers?
I would say reaction time. What I find very important, which is sometimes in the contract, sometimes not, is the reaction time. Reaction of information as well. Information flow is key. Whenever something happens on site, I think it's important that, depending on the scale, of course. If it's only a job that is not working, I don't want to know. But if there is a significant downtime, and this is to define with the O&M provider, then it would be nice to have the information within 24 hours so that we could react as quickly as possible. If it's downtime due to the grid, if it's a downtime because an inverter broke down, it's very important to have the information, because then we can prioritize as well. The thing is, we have usually a very small team of a few asset managers running each of us a few hundred megawatt, and it's important to prioritize. If it's downtime on a PV plant with a small PV plant with a very high tariff, then it's going to be a huge loss. Or if it's a downtime on a big PV plant with a low tariff, then it's going to be, you can have the losses in megawatt hours and the losses in currency. And you have to be able to make an arbitration between where you're going to put your efforts and your energy first. So yes, it's important to have the information. It's important that the O&M providers is reacting fast, that he's proactive in calling all the people involved in this specific downtime. And for me, that's one of the key: reaction time and information flow.
Thank you very much, Jacqueline. We will come back to all the discussion later, but now I want to call Duncan, because he wants also to explain us a bit better what he has done with this 73 installations. 73 installations you have bought, and you have also brought some presentations. And Duncan, I would like to address you some questions to this. So maybe let's start with, can you explain in some words, really short, we have to be a bit short now, can you explain us in some words what is your business model? You are really specialized in buying all the installations, which are good business opportunities?
Indeed. In a nutshell, we are a small fund manager who's focused on buying secondary market solar PV assets across Italy, essentially in the 1 megawatt region. So our business is more focused on the asset improvement side, because we think that acquiring assets is fairly easy. It's just a process that you need to follow and do it as efficiently as possible. I think for us, the real differentiator is that we look to optimize the performance and to maximize our returns. So that's our business in a nutshell. So if I could ask you to go to the next slide. So I just wanted to give a quick introduction to what I call business as usual, is that when we pick up an asset, just based on kind of the history, as you can see on the right-hand side, we're across the full 14 regions of Italy. Everywhere green on the map is where we have assets, and they are sort of spread, I would say, probably 70% in the south of the 73 that we're playing with. As you can see from the brief charts I put on the bottom right, you can see that we have quite a mixed bag of inverters and PV modules. But we do have kind of dominance, but that's kind of more of an Italian market trend, I would say. For Power One, for example, as an inverter supplier, and Trina Solar is quite a dominant module supplier. But as was indicated earlier, the feed-in tariffs in Italy, depending on which conto energia you have, can dramatically drive the decisions you're making. So based on this portfolio, I just wanted to give a quick snapshot as business as usual, and then I'll move on to the next one. So the availability enhancement is where we start. Prioritized operation and maintenance. As I indicated, we will do a thermography study to enable us to start focusing, because there are so many things you can do at any one time that you must start prioritizing those that can be solved quickly and those that have quite a large impact, and you sort of try and balance off the two. So we will complete what we call in the prioritized O&M scope, outstanding corrective maintenance that might have been missed by a previous maintenance contractor. We'll make sure that from the thermography reports that kind of the basic broken strings, faulty components, broken modules are all replaced, and we will then roll out the kind of the standard inverter and medium voltage maintenance, because it's kind of primarily focused around achieving that 99% availability goal for us. And then as standard, because as I sound like a stuck record, but data is key. So we will install new monitoring systems and new pyranometers, because often
Duncan, we have to move on a bit. Maybe you can come to the next slide already, because there you can show your great results which you have achieved because I think you have achieved an average and performance gain of 4.8%, and you can point out a bit how what do we see on these slides now?
So 4.8% was across the entire portfolio of 73. What I have here in this case study is I've taken the 33 assets that we bought in the last 5 months of 2019, just to drive discussions. What you can see on the left-hand side, the top chart, is I just thought I would kind of put a discussion out there to see where we got our efficiency gains. So you can see on these 33 assets as a weighted average where we got those milestones. And actually, just by doing effective maintenance and just by resolving sort of outstanding issues, we were achieving through thermography resolution of identified problems about 2.2%. Effective maintenance was a little bit more complex. I should probably dig into that. So that 4.6% was no mean feat. Our definition of effective maintenance was also doing a proactive replacement of inverter stacks. So I worked my way down the right-hand side. So module replacement. 27% of the portfolio of these example 33 assets, we ended up changing around 13% of the modules, which we were looking at really on an asset-by-asset basis was about 3% per asset. So with a nice return on investment in less than 3 years, it's modular replacement is an obvious one. You just need to flush it out quickly because it's a quick win. But what I've thrown in here, if people are looking at the bottom table, so I just thought I'd be give us all something to talk about, is that you can see that I'm showing 100,000 euros for kind of a 1% yield improvement. Now, I've included the full capex, where often through a warranty claim you can look to recover those costs, but there is a capex.
At the bottom we see the costs basically. At the bottom we see the costs, which is related to the measure which you have taken.
Indeed.
Yeah. So just to make it a bit faster, do we see then that, for example, that by largest the thermography is the most efficient and model exchange basically?
Thermography is a very cheap thing to do, which is why we'll do it, and it's quite a significant win. So you can see from the bottom, we were spending around 17,000 for these 33 assets, and you're looking at a 2.2% gain. So it's an easy win. I would say modular replacement is quite an expensive one. You're looking at about 115,000 per 1% gain, and we got us about 0.8 across the portfolio. Yeah. But for inverter replacement, it's quite a lumpy investment. So you're looking at somewhere around 200,000 for a 1% gain. But I just wanted to caveat that because there are wider considerations in that inverter replacement program. So cannibalization of old inverters for spare parts, reducing future maintenance costs. There's the increased availability, which kind of reduces the future potential business interruption risks. And also you end up with a new inverter warranty. So that capex can be quite distracting, but I just wanted to put it out there for discussions. And then there's the effective maintenance. Like I said, I put zero cost there because a lot of this can be moved to the maintenance contractor. Often in contracts, the maintenance contractor will have a certain amount of burden for carrying costs for replacement parts. And so actually you can start changing some stacks, you can start optimizing performance on your inverters for effectively zero. You just need to force the maintenance contractor into that because obviously they're not going to be the first one to volunteer putting their own money on the table to fix your problem, but it depends how you shape your maintenance contract.
Thank you very much, Duncan. I think we have to move on because now Jonathan has also access to the audience questions, better access. So Jonathan, before we come then to the panelists to comment on your input, Jonathan, what does our audience want to know? Is there something what can fit in also at the stage we have now in the discussion?
Indeed, there's a wide array of questions, as there always are, or is rather. But to Duncan, first of all, to you, one question: most of the suppliers of the modules in your projects are just not around anymore. How do you deal with the warranties?
Yes. If there is no warranty, it's a really short conversation. So we install PID as standard. So for me, PID is just a moot point. I move very swiftly on. So we put flow controllers from Padcon on every single system and eradicate PID. If you've got delamination, then you just have to replace the modules. But often we will proactively replace the modules so that we don't have continued business interruption risk during the warranty claim discussion. So from our point of view, just fix the problem and the contracts will follow. But other than that, it's one of the other things that we tend to try and do is the anti-reflective coatings. We have done it, questionable results, if I'm honest. I think the industry is a little bit in its infancy because their application processes are fairly crude in many instances, but you can get a nice 1-2% gain. And so one of the things that we are doing with our modules that are out of warranty or out of production, if the company's fallen over, is we'll put the anti-reflective coating on the modules because it's no threat to the warranty. There's often a senior debt provider will not really be open to doing anything that threatens the module warranty. So one of the benefits in many ways, if you want to sort of balance them out and look at the positive, is if your module manufacturer is no longer in business, you can apply the anti-reflective coating and get that 2% yield uplift.
Okay, thank you, Duncan. We've got one more question. A very nice feature of our event space is you can vote up and down the audience questions, and one that is hugely popular. So I'll ask this with urgency, perhaps to you, Stefan. You've got a big track record in developing projects and also O&M and owning as you've set out. What do you think are the key factors in a successful warranty claim for defective PV modules?
I think the most important part is documentation. If you have the data, then you can convince also the suppliers. And it's completely independent to modules, but it's also inverter structure, cables, and my love topic, cable ties. Yes. So in general, if you have the information, then you are, I would say, in a good shape. If the supplier is not there anymore, there is still an option. I mean, we've seen also that module companies left and they came back, but they still have the accruals on their account. So that means, I mean, let's speak about some company names. I mean, Suntech was gone and now they are back. But in the meantime, there is still a point of contact available. So that means if you have the data, if you have the right to documentation, then you have a very high chance to claim these issues. But if, for example, what we just heard, if you buy existing plans, then it's always a challenge because, for sure, if you buy 50 plans, probably they are built by 50 different EPCs, and these EPCs have a different kind of, I would say, documentation style. So I think this is for me a real challenge, and also probably a very hard work to analyze these plans. So documentation is the key of everything, and there are a lot of tools in the market. If you have the right EPC players, then you have a very good chance.
Okay, Michael, would you like another question?
Yes,
Well,
because I mean we have this very popular cable question, and I think Lucy has also some experience with the cabling from her first or second case. I forgot.
So the question is more or less, please don't only talk about solar modules. What role does cabling play? And Stefan also pointed to that in terms of park degradation and underperformance.
Lucy.
So yes, cables are an interesting case for components because they come as they are with their level of UV resistance. So first of all, we all know of famous cases where some cables were used with low UV resistance, or some cables were buried where they shouldn't have been buried. So we've heard of those cases, but there's also the component where cables can be mistreated. So if you tie your cables too tight and they come out of your panel junction box too tight with a low radius of curvature, then you can damage your connections. And this was in particular the case for the second case as well. We saw very tight cable tying, which led to some losses at the junction with the junction box of the panel. So you can mistreat your panel, but you can also have a pretty poor component to start with. So that's an interesting question. Thank you.
Yeah. Maybe we can ask, because it's really popular, this cable question, maybe we can also ask Stefan what his experience is with connectors, because you are also running quite old plants because you started early in the market. Do you see that there are problems or challenges?
Yeah, I think if you try to save money on these critical components, sooner or later it falls back on your knees, on your shoes or whatever. Yeah. So I think this was a bit when we started Enerpark in 2009. From the beginning, we've been quite, I would say, restrictive in the selection of suppliers. Yeah, let's say it like this, or we try to increase our quality expectation. So we didn't compromise on this, but we just heard from Lucy. UV resistant of cables. This is a real issue, yeah. Or for example, if you put cables in the ground and everything is labeled perfectly, but then you see that this cable is a fake, yeah. This can happen, yeah, and especially if you build outside Europe, and you know we did a lot of projects in Ukraine, Belarus, and Russia, and this is where you have very often. So you always have to take a sample and you have to test it. Yeah, if you don't do it, the stamps are fake, the documents are faked, this can happen, which is not so much the case here in, I would say, in Western Europe.
I mean, just to remember, last year at our roundtable, we had a long discussion on the burying of cables, which was really an issue. Maybe we really have to move on, but there's one question which I think Lucy can really, which is popular, and Lucy can really answer with really short, maybe with 2 sentences or 3 sentences. How did you distinguish between soiling and degradation? When you, I would now add, when you did the IV curve measurement to determine the power loss?
So it's pretty simple. We can clean the panels before and after and measure the IV curves before and after cleaning. Then in that case, we have to do that in order to determine the state of degradation of the optical layers in front of the cells. And then you can reassess your entire data without having cleaned the whole plant to normalize for the optical losses that are not due to soiling. So basically, you can easily dissociate soiling from optical degradation in front of the cells by performing some cleaning procedures of part of the plant and then reassigning the right optical losses at the whole plant level.
And I think the clue was a bit with your method, as you were looking for a representative sample of strings. You also did not clean all the strings to measure the difference, but you also there try to come along with very little number of strings, which then were representative for the whole soiling.
That's right, to basically get still accurate measurements, but at a reduced cost, for sure.
Thank you very much. I want to address a last question, and Jacqueline, please try to really be short because we have to move on. But as you opened the panel with your feed for thought, I would like you, if you have you learned something from what we had just discussed, how to relate that to what you said? Do you think that what can we learn from these cases in order to how to get the information which we need? Because I think that was your topic, that there should be transparency of the information along the whole value chain.
Yeah, what I was mentioning actually was that we should master the data, and it's going to be for everybody. What I see among the investors, the asset owners, is we try to have our own platform where we can have the technical information at the same time than our own end providers. And it's not only about a controlling function. It's just that if everybody has the same information at the same time, by the time we reach the phone and we talk about it, we are all aligned. We all know what's going on, and we know what has to be done. And I think it's about efficiency, transparency, and it's how we're going to all together perform better and bring higher yields. That was the idea behind.
Yeah, and we also heard, just to add that, we also heard from Duncan and also a bit from Lucy, how you can relate this with also the effort you have to undertake. Thank you very much to all the panelists. Jan will stay in our show because we will now have an interview with Jan. But thank you very much to all the other panelists, and we hope we have you soon back. So Jan Napiorkowski from Ariel Ray, you also brought a slide to show us more about the pros and cons of performance ratio insurances, or maybe also megawatt hour insurances, and also how to set them up. So can you give us a concrete example how such an insurance works?
Maybe let's use the slide first to just picture what we are talking about when we're talking about performance ratio. That is, at the end, everybody would like to ensure revenues of the project. And revenues are production megawatt hours times a certain compensation rate, let's say feed-in tariff. So we focus on the megawatt hour piece, which consists of irradiance and performance ratio. Now, this is applicable not only to O&M companies. There was a very strong underlining of O&M companies and O&M guarantees in the session before, but there is actually few O&M companies which really have the ability to provide sophisticated performance ratio guarantees. So we primarily work actually with asset owners and developers who go for a megawatt hour guarantee in order to secure a certain level of operational cash flows, which enable access to higher financing or cheaper financing. This is the primary goal. The one example which I've listed on this slide is related actually because we talk about O&M, about a particular O&M. It's a transaction which has been made public quite recently. The numbers are made up in this example, but close to reality. If we pick a single project where an O&M company has to provide a significant guarantee, which is significantly exceeding the fees which they're making on an annual basis, then insurance is the best way to mitigate and transfer those liabilities to an investment grade balance sheet. Right? So if you're an asset manager, asset owner, and you would like to have a wider performance ratio guarantee, which comes with a larger amount of liabilities on the balance sheet from the O&M companies, it is a way for the O&M company to move those liabilities from their balance sheet, focus on performing the performance, the maintenance of the project, be responsible for so-called frequent smaller losses, which could oscillate around the guaranteed level. But in the more unexpected scenario where larger drop in performance ratio would be caused, is it modules or soiling or a combination of multiple things, then a larger liability would be paid from an insurance policy, which would provide the liquidity to the O&M to pay their liabilities to the asset owner.
And when you do, but you also already mentioned that you also insure asset owners and asset managers, not only O&M. What is the advantage for the asset managers at the end? Would that look similar, or how would that look like? How would that work?
Well, operation maintenance companies, they never take weather risk, obviously, right? So that's why performance ratio is the metric, or availability is the metric. You define it. Now, in order to move it to the next level and to include irradiance risk, we come up with a megawatt-hour guarantee. Right? Now, assuming that the PPA is investment grade, or there is a feed-in tariff, which you can assume that what monetizes the energy production is stable, or let's call it investment grade. By providing a production guarantee and ensuring megawatt hours of the project, you actually provide a floor on revenues of the project. So asset managers use it to guarantee a certain level of operational cash flows of the project, and this can be used for various purposes, for internal risk management, for actually using the insurance company to wrap around all the underlying guarantees instead of just a particular guarantee, or to source better financing conditions.
I mean, there's a saying which is insurances insure everything. One just has to pay for it. I mean, obviously, there's then the question: how much does it cost to have this? Just having insured everything, and to make it more concrete, for which sort of asset owners would that make sense?
Well, okay, it sounds like the question indicates that insurance is expensive, because if you want to insure everything, it will cost. Not necessarily. It depends on how close you want the insurance to attach, so to say, so to ensure of your expected production performance ratio, etc. Right? So the example which I used for the O&M performance guarantee, I mean, talking about 97, 98%, these are pretty high numbers, right? But at the end, if you want to backstop all the liabilities which the O&M company has, you have to go quite high and ensure a very high level of their guaranteed offering. If you talk purely to the asset owner, and if the goal of the insurance is, for example, only to ensure cash flows which correspond to debt service, for example, or a certain equity coupon payment, you don't need to insure likely 95 or 97%. Right? Maybe it's enough to insure 85 or 90% of the expected production for the expected revenues to make the bank the beneficiary of the policy. And this is already a policy which keeps a significant buffer between the expected production and an insured production, which is justifying the cost of the insurance to protect a third party, but that doesn't have to be expensive because you're insuring a purely catastrophic event, which is not something which is expected on an annual or every 2-year basis, right? So if you have good quality and if you are insuring more unexpected catastrophic events, insurance will not be expensive. If you're trying to use insurance,
for example, I mean, because when I heard it the first time, I thought that is something for the more unexperienced asset owners who are maybe not so sure how to really control the quality of the service providers and of the plant itself. But when I hear you now, you would say it would also make sense, for example, for such experienced asset owners, like we just heard, Enerpark or Allianz.
Yes, and I think the announcement which was recently made about us supporting the NovaSource acquisition is the best example of this, right? I think experienced asset owners expect wide guarantees from their O&M providers. They use professional O&M providers who have the ability to monitor and validate quickly such performance guarantees. And this enables risk transfer to a much stronger balance sheet, like an insurance balance sheet, right? Insurance, unfortunately, will be, unless the insurer is doing proper underwriting, insurance should not be a replacement for quality, right? So the goal of insurance is to provide a much higher protection in a dollar term than the asset manager or O&M company can. Let's say afford in brackets themselves from a cost of capital perspective, right? Insurance is supposed to be cheaper capital to owners and asset managers, so they can mitigate their liabilities and for catastrophic events to a different balance sheet, instead of keeping those accruals on their balance sheet.
Jonathan, are there audience questions on this insurance topic? I mean, we shouldn't. I see there are a lot of other questions still.
Not specifically on insurance at this stage.
Yeah, so that maybe also for information to our audience, we will send around the questions to the experts, and we will let you know where you can find the answers which we get. But then I have another question to you, Jan. I mean, when we first talked about this, you also said that you think that such insurances are particularly interesting also when you want to get new investors, new entrants into the market. You, as far as I understand, are also maybe not so keen on the very high ROI, but also more keen on really risk mitigation. So what sort of investors could that be?
Yes, I mean we have been insuring project performance for about almost 5 years now, and we used to do it on single projects for particular projects where there was a particular demand to support a transaction, usually debt finance transaction. Now, it's really more the interest from larger O&M, larger asset managers, usually let's call them the safe equity. So, for example, pension funds, who have a less aggressive expectation on the returns, but also have a much more conservative expectation on the stability of the return, right? So, and if you're able to combine a big portfolio of projects.
Jan, sorry, I would, because I think we have only 1 minute left, and we have one very important audience question here, which I think it's the second one, which I think is really so maybe you can then answer that, because I think that is good to answer, and maybe you can do that very short.
Indeed. Some investors say that if they have a big number of PV plants, they can cover the risk of quality issues in the plants, and the cost is similar to the premium of the insurance. What do you think about that?
Well, I cannot answer that question because I don't know what particular portfolio of plants this is referring to. I mean, maybe I'll answer it this way. If somebody has a big portfolio of plants and let's say 1 gigawatt portfolio of plants, and they expect to have really small replacement issues and small drops in expected performance, causing slight loss in revenues over the entire portfolio, it will be more expensive to buy insurance than to do it themselves. Yes, probably yes, because you're basically swapping cash. you're giving cash to the insurer, so they pay you back for what are essentially expected losses to happen. That's not the purpose of insurance. The purpose of insurance is to buy insurance for unexpected events, which would cause us a severe financial damage to the project, and a damage to your liquidity. And this is what you buy insurance for. And this will be always cheaper than doing this on your own balance sheet, because of the diversification that insurers get from their insurance book.
Thank you very, very much, Jan, for being with us and sharing these ideas with us.
Thank you for having me.
Thank you very, very much. We move on. So now I welcome Andrea Viaro. He is Head of Technical Service Europe at JinkoSolar, and he will present about the role of quality and innovation in protecting assets. So we will start a bit earlier in the value chain at the construction, but I can promise you at the end there is also something which is really important for asset management. Andrea, just start, please.
Good morning, Michael. Good morning, Jonathan, and thanks for the audience for joining this session. The purpose for me today is to somehow link to the discussion that we saw in the previous session to describe to the audience probably what manufacturers can do practically, PV modules manufacturers in particular can do practically to mitigate the risks that asset owners and asset managers can of course have with investments on PV plants, and to of course give an overview on what aspects we focus on and we can leverage on to make sure that the investment is profitable, that the plant will perform according to expectations, and ultimately to have consistent of course LCOE according to expectations and business plan estimations. As we know, the LCOE and return on investments is very much related to very general aspects like CapEx and OpEx, which are very well known, and of course energy production. But probably we tend to underestimate in some cases how operation and maintenance of the plant have a strong impact on the LCOE level and on the performance of the PV modules in particular, or the durability of the PV modules. And that's exactly what I will go through this presentation describing and showing how important is the involvement of the module manufacturers or component suppliers in the complete value chain to make sure that actually the estimations initially done from the investors are supported by the real performance and behavior of the components and the modules in particular for the PV plants. The fact that manufacturers like JinkoSolar are fully integrated and vertically integrated, controlling the complete value chain production from the raw materials up to the finished product, gives the possibility to start, of course, this process and control not only the components and the cost, of course, of the supply of the finished product, but also the quality by selecting, of course, the first class components, the production processes, and all the quality control steps that allow us to have the best quality possible in production, starting from R&D and controlling also, and that's also the topic that I want to address in this talk today, how technology and innovation can really help to mitigate the risk and support the development of new projects in terms of profitability and reliability of the components. For example, the technology innovations that we saw in the past, starting from the half-cut cell technology that already mainstream is today in PV modules production, allowed not only to increase the module power class and efficiency of the PV modules, but also to increase the reliability in the fields. There is, of course, we all know how the losses are mitigated through a half-cut cell configuration of the PV modules, but probably it's underestimated or not completely understood, for instance, the reason why that's important, especially going to larger wafers, larger cells, as the current levels of the modules increase, and that's important to mitigate the effect like hotspots that might happen in the field due to simple soiling or shading. We will see later in the last slides what can happen to a module when these conditions happen. And that's explained here how different is the behavior of the module, for instance, comparing a full cell type with a half-cut cell type. In these estimations with field measurements that we also did in our R&D center, we really practically estimated a thermal gap of around 20 degrees of the hotspot developed by a half-cut cell module or full cell module. So this is, of course, a proof and an estimation of the incremental reliability that we can have on the module, not only focused on power class and efficiency. Another aspect also related to half-cut cell configurations or half-cut cell modules, but also going towards the new series of modules that we have launched with the Tiger series, for instance, is the fact that the half-cut cell module, of course, mitigates indirectly the possible impact of microcracks. The propagation of cracks is clearly reduced by 50%. There is a pattern that the cracks can follow, but cannot. Of course, it's limited to the border of the cell. And in this way, of course, by mitigating the propagation of the cracks, we can also increase the long-term performance, the long-term reliability of the modules, and the same can be achieved and actually even increased thanks to the incremental number of bus bars or wires that we normally use now in mass production with the new generation of modules. We moved from a traditional flat ribbon 5 bus bar configuration, for instance, to a 9 or 10 or even more metal wire connection, which also decreases the potential impact of microcracks because of the shorter pattern that can be impacted by this behavior of the module or damages that can occur to the modules. Talking about the Tiger series, the new one in the portfolio that Jinko launched really recently, also the overlap of cells, of course, allows to increase the module efficiency and module power class. But there is a lot of study behind these critical points in the module production and construction, which is very delicate, clearly, and has to be made appropriately. And that's the big study that also Jinko was developed to design this area of the module and overlapping area of the cells to make sure that there is no stress to the cells induced and creating potential cracks or damages to the cells. So special attention to the shape of the ribbons, for instance, was made, and the EVA composition or thickness to make sure that there is enough buffer cushion effect of the EVA, for instance, to limit the cracks or the module's damages because of this different combination or construction of the module. We discussed many times previously also how important in other webinars or presentations how important is the components used, and we saw in the previous sessions also the POM participating, and how important is the aspects related to the module composition and components selection to make sure that the modules can practically operate reliably for many years. And that's the reason why we, of course, selected the Tedlar-based backsheet as the most reliable material used for modular construction, because it's still confirmed the material with the lowest failure rate in the field. And that's exactly what we want a module to behave, how we want a module to behave, because, of course, it's not easy to estimate the long-term failure possibilities. The certificates, as we all know, estimate only the infant mortality or the initial lifetime of the module and behavior. So it's not easy to determine how the module behavior will develop in the field. But thanks to studies and reliability analysis of components used in the modules, it's possible to make sure that they will behave according to expectations, according to warranty terms. And we also know, as Stefan was commenting before, how important it is to make sure that warranties are kept and manufacturers are still in place. Otherwise, we, of course, have to consider alternative options to protect the asset owners and asset managers from the inherent risks in a PV plant development. But from the manufacturer side, what, of course, we can do and we do is to not limit our responsibilities or involvements up to the shipment of the modules from the factory, but we try really to guide the installers, the EPCs, and the asset managers, operation and maintenance companies throughout the lifetime of the modules in the field to make sure that they are installed, operated, and maintained in the proper way. So we put a lot of efforts in covering also this downstream part of the value chain, and of course we cooperate with many other third parties or independent companies, for instance, to support us with this, even in production or even in the field. We know many third parties companies like CEA or STS, for instance, as independent inspectors in the field, which really allow to control the module operation and beyond the installation guidelines that we might have from the manufacturer sides, but really making sure that the modules are really installed and operated and maintained in the proper way. This integration in the value chain is very important. I was mentioning third parties companies, which are entities that, of course, we as manufacturers operate with to control and make sure that the quality of the components in production is up to the buyer expectations, but also in the field. There is different companies. I was just mentioning two of them earlier that can control the modules conditions in the field. And we practically cooperate with also these third parties very actively, because of course it's important for us to make sure that even down to claims or quality problems that might be detected in the field, the analysis is made properly. There was a question earlier also about how to effectively manage a warranty claim. We can address that probably later in the question and answer session. But clearly, the first step is really to manage the analysis and evaluation of the module conditions in the field together with the manufacturer, because that's the best way to have a common understanding of the situation and what could be wrong with the modules and how to solve the potential problems that can happen. In these pictures, for instance, is simply shown a typical example of worst practices that we can see in the field, and clearly we don't want to see this happening in the field, and that's the reason why even when we do our thermal inspections in the field, it's very important to understand what happened to the modules. So it's very important the integrated communication with operation and maintenance companies to understand how the modules have been installed and operated, to understand why they developed certain failures in the field. And last but not least, we were talking about maintenance and cleaning, for instance. We know how, of course, modules has to be maintained and cleaned. PV arrays and PV plants are not maintenance-free, but clearly with a minimum best practice in maintenance and cleaning processes, it is possible to make sure that the modules really are reliably working in the field for many decades. But in many cases, of course, we know how heavy soiling or shading or potential problems like similar situations in the field could affect really the performance, first of all, of the modules, but also the reliability, which is really incremental risk that the asset owners are taking, and that's important to really work together also with the upstream suppliers to understand how the modules behave, why the modules might develop such failures, and how to solve them ultimately. Thank you very much, and back to you again, Stefan. Sorry, Miguel.
Solar. Two quick questions I'll get to you straight away from our attendees today. The first one is, if IR is not as reliable with half-cut cells anymore, would it not be better to switch to EL, electroluminescence analysis? Okay, interesting question. Let's say short answer is that EL and infrared is a very similar technique. It's a different signal that is detected by the sensor of the camera, but the information that might be collected are in some way similar. Of course, electroluminescence is more accurate when detecting properly cracks on the PV modules. But I would rather say that the two techniques integrate well into a well-done analysis, but give different information. So replacing infrared, it's probably not a solution, also because infrared is still faster than electroluminescence, and it's a good starting point to have a first assessment of the PV plants
performance or situation for sure.
Okay, and an immediate follow-up, that there will be new IR patterns for high-density modules, which is like the Tiger module that you did set out. Do you have experience what failures would look like with IR, with these kind of high-density module formats?
Well, the possible hotspots or thermal patterns that we might see on a Tiger technology modules or previous generation cheetah half-cut cell, for instance, is rather similar. What is different in the Tiger module is the interconnection of cells with overlapping cells and multi-busbar electrical connection. But in terms of crack developments, of course, apart from the mitigation of the risk, thanks to the limited crack propagation, thanks to the multi-busbar interconnection and the half-cut cell configuration, but the potential hotspots that might develop are very similar to a previous generation of cheetah half-cut cell module in reality.
Okay, well, we've only got just a couple of minutes left. One more question, Michael. You set out the Tiger module with the tiling ribbon. How does it behave under thermal cycling stresses, given how close, or in fact the cells are very slightly overlapping, and how unique that ribbon structure is also?
Very good point, and that's why I was stressing out during the presentation the importance of the reliability of the overlap area of the Tiger modules with the tiling ribbon technology, because there was a lot of study on that also internally in GIMCO, thanks to our R&D team. And the fact that the modules are not physically interconnected at the overlap and they are not glued together allows them to physically follow the movements induced by the thermal expansions or thermal stress that might affect the modules. And that's why, and also the multi-busbar interconnection allows them to move freely somehow and reduce really significantly the impact of microcracks that might happen induced by these thermocycling tests or accelerated aging tests.
Okay, thank you, Andrea.
Thank you very, very much, Andrea. Yes, now we have to come to the end of the whole session, I think. We want to address the last question to Andrea, what we discussed, because Andrea, you also, I think you also has seen the panel discussion. Do you think we have got to somewhere? Do you have seen some takeaways you can bring home?
Well, I think a key point that I was also somehow trying to summarize in the beginning of the presentation is how important it is to integrate the complete value chain in the PV industry. And I think we are now seeing that from the technology innovation point of view, how important it is to integrate, especially with the new technology of modules, the components into the system to make sure that really the LCOE is the lowest possible. Talking about modules integrated in PV trackers or working with inverters which might have to accept higher level of current. So there is a lot of study and work and challenges, of course, related to that, but that's important how the manufacturers are working together to really make sure that the components work properly in the field. And I think, and I really believe in the downstream, also in the assets management side and operation and maintenance side, it's very important to keep involved the component suppliers, not only when there is a problem to solve a warranty case problem, but really to make sure that the quality value chain is kept intact, and that the modules produced with high quality are still operated with high quality standard in a field up to at least the end of the warranty validity at least, but definitely for a long time.
Thank you very much, Andrea. Thank you very much for joining.
Thank you, Miguel. Thank you, Jonathan. Goodbye.
Okay, that was our asset management session, the first session which we have. Jonathan, you will have the quality session this afternoon.
It was very nice to hear a lot of quality discussions or quality themes touched on during this first asset management session. So please do stick around. It's just an hour and 15 minutes or so until the quality roundtable. I encourage you to visit that. A whole host of themes being discussed, some of which we touched on in this session, but a lot more detail, things like floating PV, larger wafer sizes, and really that's just the beginning. Yeah. So I encourage you to stick around.
Yes, and just to finish the session, thank you very much to our sponsors, DuPont for this session particularly, Platinum sponsor, DuPont Photovoltaic Solutions, GIMCO Solar, and I Will Ray.
And of course, we encourage you to get involved with all the other attendees on this event app. Now, the networking functions are being sponsored by FEMA, so thank you very much to them for supporting us in letting you network. There's a host of ways you can network on chats, in group discussions, one-on-one video networking via Zoom, and of course, meet the speakers as well. So you get the chance to interact with our speakers. The speakers who are available immediately after this session is Stefan from Enerpark, Jan from Ariel Ray, Lucy from DuPont, Andrea from Jinko, and Duncan from the LCF Alliance. Michael, well done. Great program that you put together. Thank you very much for all the thought, work and effort that's gone into it. And thank you for your fantastic questions. Stick around, stay on the app for these PV Magazine roundtables and get involved.